All right, chapter 9, section 1. We're talking about the Pythagorean theorem. Hopefully some of this is review. Starting off with a theorem, the Pythagorean theorem, 9.1. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So that's quite the long statement here, but it's written over here. We have c squared, that's the hypotenuse. And then it says the sum of the squares. So here's the squares, and there's the sum of the lengths of the legs. So that's what that's saying. Normally it's written backwards as a squared plus b squared equals c squared. It can be written either way though. A Pythagorean triple is a set of three positive integers, normally called a, b, and c, that satisfy the equation, right? So anytime we have a right triangle, it follows this rule. But there's some special right triangles that follow this rule and have nice side lengths, integer side lengths. So here we have four different groups of them. This left one here, we have the 3, 4, 5, right? And then you look at the second row there, you could double it to be 6, 8, and 10, right? And then the next one would be multiplying by 3. So anything that is a multiple of 3, 4, and 5. The next one's 5, 12, and 13, 8, 15, 17, and 7, 24, 25. Now, while these are all Pythagorean triples and they all satisfy the Pythagorean theorem, the ones that we're going to look most at, or the ones that we're going to use most, will be these here, the 3, 4, 5, and the 5, 12, 13, okay? And these would be good things to memorize, especially the 3, 4, 5. That one's almost always a problem that's on some kind of test or something that you see that you could do it by using the plain old Pythagorean theorem, but if you remember Pythagorean triples, you can just skip the Pythagorean theorem altogether and just write the answer down, right? So if it was given to you that there's a right triangle here, maybe this is 5 and this is 4, then you would know immediately that that missing side length is 3 because you knew Pythagorean triples. So it would be a good thing to memorize the 3, 4, 5 and the 5, 12, 13 Pythagorean triples. Example 1, find the value of x, then tell whether the side lengths form a Pythagorean triple. Well, I can't help but look, well, we'll just do it the normal way. We have the hypotenuse x, so I'll say x squared, and then I have my sides, 8 squared and 15 squared. So in my calculator, I'm going to type in 8 squared plus 15 squared, and I get 289. 289 equals x squared. I take my root, and regular plain old x will be 17. So this side length here is 17. And yes, that is a Pythagorean triple. It is a Pythagorean triple. So this would be an example of one that if you had known this Pythagorean triple right there, if you had memorized that, then you could look at this problem and you could just write down the answer. You wouldn't have to actually do that math on the left side. And that's not a lot of math, but on an SAT, on a standardized test, that could be a lot of time. All right, example 2, we're again finding the value of x. So we have we'll say x squared plus 12 squared equals 16 squared, right? The 16 is the hypotenuse. It's always the opposite the right angle. Because I'm lazy and I don't like to type things in my calculator very much, I'm going to move this 12 squared over here on the right side. I'm going to say, well, this is the same thing as x squared equals 16 squared minus 12 squared, right? That way I only have to type it in one time to my calculator. So now I type in 16 squared minus 12 squared, and I get x equals 112. X squared equals 112. Taking our square root, I have x equals square root of 112. It doesn't come out perfectly. What we're going to have to do here is we're going to have to put it in simplest radical form. So I'm going to take my 112, and I'm going to split it up. I know that it's even, so I'll just go ahead and divide by 2. I have a 2 and then 56. Dividing by 2 again gives me 2 and 28. And then I have 2 and 14, 2, and 7. Now I'll circle my pairs. I have a pair of 2's here, a pair of 2's, and a single 7. Because it's a square root, we're looking for pairs. I have 2 pairs of 2's, so this will be the same thing as 2 times 2 root 7, right? I have 2 pairs of 2, and then a leftover 7. The 2's combined to be a 4 root 7. And that's my x. And then, does this form a Pythagorean triple? No. And it's no because we did not get an integer answer, right? A Pythagorean triple always has to have 3 integers. All right, 9.2, the converse of the Pythagorean theorem. So this one, converse, right? We think of converse as thinking of something as backwards, right? So it's the Pythagorean theorem only backwards. And you guys can read that text there, but it says here, if c squared equals a squared plus b squared, then the triangle is a right triangle, right? So it's going backwards. If you're given that the sides, and you're able to plug the sides into the Pythagorean theorem and it comes out to be true, then you know it's a right triangle. So example 3, we're going to tell whether each of these are right triangles. Now before we can start plugging these in, we need to make sure that we know which side is longest, right? With this square root there, I don't know how long that actually is. So I'm going to type that in my calculator, square root of 306, and that gives me 17.5. And again, the only reason I'm doing that is to make sure that I know which side is longest, right? Because if that had given me 14 or something like that, something less, then I would have to treat the 15 as my hypotenuse, as my longest side. So now that we know that's the longest side, I'm going to take my legs, 9 squared plus 15 squared, and then I'm just going to put a box here because I don't know if it's equal or not, and I really don't want to say that it's equal. I don't know that it's equal yet. And then I'm going to put root 306, and then I'm going to square it. Again, the box is just a placeholder so that I keep the numbers separated. Whenever I square these, whenever I plug it in, I'll say 9 squared plus 15 squared. That gives me 306. On the right side, my root and my square cancel, and I get a 306. Well, those are equal, so yes, it is a right triangle. So I can say it is a right triangle, right? And that's RT abbreviated for right, and that's a little triangle there. It is a right triangle. And the right angle would be right there, right? It's opposite the hypotenuse. All right, in this next one, I'm going to start off by typing in 2 root 35, and that gives me 11.8. And again, the only reason I'm typing that in is to make sure that I know which side is longest, so that I know which side to treat like it's my hypotenuse. So just like in the last one, I'm going to now plug in, I have 8 squared plus 10 squared, and then I'm going to put my box here, and then I have 2 root 35 squared. On the left side, I'm going to have 164, box. And then on the right side, you kind of have to think about this as the exponent here is distributed to both of those pieces there. We have 2 squared, which is 4, and then the square root of 35 squared is just plain old 35. Now whenever I type in 35 times 4, I get 140, which is not equal to 164, so this is not a right triangle. Okay? Now we were able to, from what we know so far, we were able to say that the one on the left was a right triangle, and we were able to say that the one on the right is not a right triangle, right? This next theorem, the Pythagorean Inequalities theorem, is going to let us not only say that this is not a right triangle, but it's going to let us categorize it as a obtuse triangle, or an obtuse triangle, or an acute triangle, all right? So next up, the Pythagorean Inequalities theorem. For any triangle ABC where C is the longest side, the following statements are true. And I always think about this as the C being the hypotenuse because it's the potential hypotenuse. So I'll probably refer to it as the hypotenuse, but really the hypotenuse, it's only a hypotenuse if it's in a right triangle, right? But I'm going to still refer to it as a hypotenuse here. We have C squared, which we normally refer to as the hypotenuse, is less than the 2 legs squared, right? If the hypotenuse, here I'm just going to say hypotenuse is less than legs. If the hypotenuse is less than it, it is acute, right? Think hypotenuse is smaller, so it's acute. And over here, we have the hypotenuse is greater than the legs, then it is obtuse. So the hypotenuse is larger, then it is obtuse. All right, number 4. Determine whether segments with lengths of 4, 6, and 9 centimeters form, that's supposed to say form right there, form a triangle. And then our next question is, if so, is the triangle acute, right, or obtuse? So we have 2 questions there. For starting, we need to decide, is it a triangle at all, right? Could it make a triangle, right? And to make that make sense, I just want to have an example here. If we have a 6-foot board, laying on the ground, and you also have 2 1-foot boards, you could not make a triangle with those, right? They wouldn't end up making a peak. They wouldn't be able to touch, right? So obviously, if it's 1, 1, and 6, it does not make a triangle, okay? The actual thing we're going to use here is we're going to say, well, A plus B, where A and B are the side lengths, or the shorter side lengths, it has to be greater than C, okay? So the 2 shorter ones added up has to be larger than C. So that's what we're going to use here. We're going to say 4 plus 6 has to be larger than 9. Well, 4 plus 6 is 10, which is larger than 9, so we can say it forms a triangle. So we know it forms a triangle. We don't know what kind of triangle, but we know that we could make a triangle out of those 3 sticks. Now we need to decide if it is acute, right, or obtuse. So I'm going to take my longest side, my potential hypotenuse, that's 9 squared. Then I'm going to use my box again because I don't know if it's going to be equals, greater than, or less than. And then I'm going to say we got 4 squared plus 6 squared. Well, 9 squared is 81. And then I'm going to type the others in my calculator. 4 squared plus 6 squared, that gives me 52. So here, we can say that 81 is greater than 52. So the hypotenuse is greater than the legs. The hypotenuse is bigger, so it's going to be obtuse. This is an obtuse triangle. An obtuse triangle. On your homework, there are going to be problems that are like this, where it first asks you, is this a triangle? And then after you answer that, you have to say what kind of triangle it is, acute, right, or obtuse. If this problem, after this first question, if right here we would have said, well, that's not a triangle, then we would be done. We wouldn't have to do the next piece. All right, number 5. Find the missing side length and tell whether the side lengths form a Pythagorean triple. So here we have 4 and 3. Well, that first Pythagorean triple was a 3, 4, 5. So x equals 5. And yes, it is a Pythag triple. Okay. See how that was much faster, much easier than doing the Pythagorean theorem. Next up, we have 16, 30, and x. This would be the same thing as 8 and 15. I think that is a Pythagorean triple. 8 and 15. What is that? Let's go back up to the front page. 8, 15, 17. Right there. So these are both 2 times 15, 2 times 8. So this is going to be 2 times 17. So what's that going to be? 34. Let me type that in just to make sure. 17 times 2, 34. So I was able to use the Pythagorean triple and make it 34 really quickly. If you didn't remember that, you could also have said, well, x squared equals 30 squared plus 16 squared, and that would have given you the same exact answer, right? So we said that this is 34, and we just need to say it is a Pythag triple. All right, next up, number 6. Just like in the problem I did earlier, I want to type in the square root of 57 to get a decimal, just to make sure that's my hypotenuse. This is going to be 7.5. So that's my potential hypotenuse. And we're just supposed to tell whether it's a right triangle. So we don't really need to say if it's acute or obtuse. We just need to decide yes or no, it is right. So I'll say 3 squared plus 7 squared. Then I have my box. And then root 57 squared. Well, typing in my calculator, 3 squared plus 7 squared is 58. Root 57 squared is just plain old 57. This is not equal, so it is not a right triangle. Not a right triangle. All right, next up. This is the first one that it's really not obvious which one is the hypotenuse. I really don't know if it's the 11 or the 5 root 5. So again, we need to type it in, 5 root 5, and that gives me 11.9. Now we know that the 5 root 5 is the hypotenuse. It's the longest side. So I can say 2 squared plus 11 squared box 5 root 5 squared. Well, the left side, whenever I type that in, I get 125. On the right side, again, we kind of think about this square distributing here. So we're going to have really 5 squared times 5, 25 times 5, which is 125. They are equal, so it is a right triangle. All right, example 7. All right, this is our last one. Determine whether the segments form a triangle, and if so, is it acute, right, or obtuse? So starting off here, I need to take my 2 smaller ones, my 2 smaller lengths, and make sure that they add up to be larger than the long one. So I'll say 5 plus 12, and that has to be larger than 13. Well, 5 and 12 is 17, which is bigger than 13. So we're good on that. We'll just put a check mark there to say that we're good. Now we need to decide if it's acute, obtuse, or right. I like to put the hypotenuse first here, the longest side first. So I'm going to say 13 squared box 5 squared plus 12 squared. Well, 13 squared is 169. 5 squared plus 12 squared is 169. So these are equal. So this is a right triangle. All right, let's look at B. Again, we need to decide, is this a triangle? Is it a triangle at all? So I'm going to say, well, 5 plus 7, well, that better be bigger than 8. Well, 5 and 7 gives me 7, 8, 9, 10, 12. 12 is larger than 8, so again, we're good. I'm just going to put a checkbox there, or a check mark there. Now to plug into the Pythagorean theorem, or the Pythagorean inequality, and I'm going to say, well, 8 squared box 5 squared plus 7 squared. Well, 8 squared is 64. And then 5 squared plus 7 squared, that is 74. So here, the hypotenuse is less than the legs. The hypotenuse is smaller, so it's acute. So this is an acute triangle. All right, part C. Again, we need to check about about whether or not this is a triangle at all. So I'm going to say, well, 2 plus 11 is greater than 102. Well, 2 plus 11 is 13 is greater than 102. Well, that's not true. So I'm going to put a slash through that inequality to signify that it's not true. And I'm going to say not a triangle. And we're done. We don't have to continue on because it would be nonsense asking ourselves, is this a acute, right, or obtuse triangle? Because it's not a triangle at all, right? All right, so that is the end of those notes. Make sure that you have, where is it? Make sure you have these Pythagorean theorems copied down, or at least, excuse me, the Pythagorean triples copied down. And then also, where's the inequality one? Make sure that you have this inequality theorem copied down. All right, that's all.